So at the end of the day, we now have 2 work in progress sessions and then our discussion with TCT members. The first in the work in progress session is Martyn Smith, and he will tell us about session management library. Martyn.
Right, so my name is Martyn Smith. I work for a company called SpaceBell, which is a Belgian company to start with. And I work in their Toulouse offices, which are just near the CNES, which is the French space agency. And we mainly do software for the space industry. In Belgium, they work on flight software for some small satellites and ground control center software. In Toulouse, it's mostly simulation software, satellite simulators, and lots of small data analysis tools, which I work on, basically. So, what exactly am I going to talk about with the sessions? So, what is the problem? We have lots of different tools. That one? All right. We have lots of different tools which produce data. So this tool here will take telemetry from various satellites. I think we've got nearly 30 different satellites and Mars rovers and some balloons as well now. And we can basically choose which data we want to look at, and it can extract telemetry parameters and then combine them using standard ground computing formula, and it will write them out to a data file and send the file to either a text editor to see the results, or what we call a presto plot, which is basically draws the data, and it has a calculator with some fairly simple calculation functions, and an FFT analyzer, which they use sometimes these days. We also have another tool which basically takes all the logs that are produced from the satellite. So they're telecommand logs which are sent to the satellite, which are all dated. We have error reporting logs, we have execution logs, anything that's produced by the satellite, or other ground support equipment for the AOCS systems. And they can visualize certain bits of data, and it can extract and filter and combine data from several different logs at different time points, and either send it to the plotter or a text editor. And the problem we have is, I'll come on to the next slide, I think. Oh, wait, no, we've got a problem. The problem is, these are all different executables, and every time we want to extract some data, we want it to accumulate in one executable instance of the program. So the same thing for the editor. It'll be useful if the editor can open several files at the same time, that we can just say, send this file to this editor and not another editor. That was basically the problem we had. So, right, they sometimes change what parameters they want and just add a new parameter, and come here and say, we'll just draw that in there as well. So the first solution we had was basically, we had the executable started a socket server on the machine, and if the server was already running on the machine, then this is not our instance. We just send the command line or the list of files to open to the server and then shut down. That works perfectly well as long as we only want one copy of the program. So, hang on, where's we go? There we go. So the problems we had with this was initially, if you wanted to not have a single executable, we changed the setting in the preferences panel. You had to leave the program to shut down the server and start it up again, and then every time they edit the data, they have 6 or 7 different instances open, and it was just quite complicated. And then on the Linux machines in the control center, it gets a lot more complicated because the machines can have several users, and each user has to have their own identity of the user of the socket server and so on. So it makes it very, very difficult to have multiple named or identifiable instances. So for quite a few years, one of my colleagues was saying, we have to do this, we have to do this. So this is basically what we were looking for in an ideal solution. So it has to be multi-platform, so Red Hat, Linux in the control centers, and Windows on all their personal computers. No centralized server, so we don't want to start up the machine, start a server, and then distribute the data through a server. We want automatic discovery, so it would be useful if the programs can discover that the other programs are present and identify them and so on. It will be useful to be able to change dynamically. If we're analyzing a problem and we have the tracer open with lots of different data displayed and so on, and somebody said, can we just look at this one? We don't want to, we want to create a new instance dynamically, say this one we finished with this one, and then connect to the new one and so on. So there you go. And obviously as stable as possible. If one of the programs goes missing, obviously the central server solution, if the server goes down, then nothing works anymore and there's no communication between things. I'm probably talking too fast, so here we go. So basically, the biggest problem we had was how can two programs discover each other if we don't have a server to communicate by? So the first approach we found, we thought about, was multicast, standard multicast messaging. So the first copy of this library, we used multicast. There's a library of EuroTcl which uses that. Got all that working, integrated, tested, worked perfectly on our site. We got into the CNES, and Multicast doesn't send anything anywhere on any of their machines. Apparently, it's all blocked by their firewall, I presume. We didn't want to go and ask their security systems what was not working.
It could also be a router. Could also be a router setting not to forward any.
But we're on a local machine. We're not. The point of the system is to all this on one machine, not.
Our way.
Yeah.
But then
there's probably a routing probably as well. Yeah, well, the CNES being a lot of some of the satellites are military satellites, and they're very heavy on networking security, or various other security as well. So where are we? Multicast. Yeah. So obviously we had back to the drawing board. No, the multicast wasn't working. So then the second iteration, we had everyone starting a server. Now we had the first program started its server, and then the others connected to it, and then we had tried to make sure that if the first program disappeared, somebody else took over. So one of them would volunteer and they'd dispute it between them. That wasn't very good. We had a lot of timing problems and synchronization problems, and yeah, it wasn't a very good solution. And then one day I was looking through the TCL documentation on WInfo, which is lots and lots of different things in WInfo, and I found name. So basically a TCL application, or a TK application mostly, can give a name to its instance, and with the command WInfo interps, the other applications can see what other interpreters are executing. And then a little while later, I discovered, what's it doing? It's going backwards, forwards, there we go. I discovered that on Windows, there's a very similar command called DDE server, which does more or less the same thing, but with a slightly different syntax. So the idea I had was to use these names to give an application name and a port number for a socket server, and then using the DDE services TCL eval or WinInfo interps, listing all the available TCL interpreters with the corresponding app name and their port ID. So basically, every application starts a server automatically. They all publish their port ID using the WInfo or DDE mechanism. I hope somebody's not going to tell me that it's very dangerous to do this sort of thing, because we're going to get stray messages coming through. And then whenever they want to ask some information or about a name or change a name, they just broadcast, they refetch the list of the current applications and send out, we connect as a socket server, socket client, and send out the request that they want, the message. So a very, very simple protocol. When we start the application up, we start the server, we get the list of current other applications in the same name, and then we just send out a request, is somebody using this name? And if somebody replies, then we use the old mechanism, sending the command line to the first program and then leaving. If the user wants to change dynamically the default, we basically just send the name change to everybody else and the name of the configuration file. And if another application is using the same configuration file, they can just save the name in their configuration file. And then the last one to leave will have the correct configuration. And the last thing is, if the user decides that they want to put an instance of the application, just change the name temporarily. We just make sure that this name is not being used. There we go. So, last thing, just a quick idea of the protocol we use. So all the messages are sent with a header, the server ID, the username. Obviously on the Linux we don't want the same application being communicating between different users, or at least not for the moment. The process ID of the application and the host name. So we make sure that if somebody's on another machine trying to inject the things, we make sure that we're on the same host name as the messages. So we basically have a very, very simple protocol. To check if the name exists, we send the message with the command exist, and if the name is used, the server just sends back the message used, and we don't use it. The same thing for default. If an ini file, we just change the default. That's about it. There's just 2 messages, 3 messages with the use message coming back. The editor has just 1 or 2 extra bits. We can ask all the other editors to send their name, which allows us to send a file, to push a file from one editor to the other by just asking all the list, proposing a list in the menu of the current open editors and just sending an open file to message to the other one. And that's all that we've implemented so far. I'll give you a quick demonstration if you like. Obviously, in the future, it would be very interesting to be able to send data from one. So we got a graph that we want to send from one instance to the other with the plotter. So if it comes through here, where are we? Console. Alright, if I come here, I could never remember the syntax correct. So if I ask here, we can see that there's one program which is my editor, which is, I can show you now. Here we come. Oh, let's get rid of some of these panels. Up. Hey, come on. No, I've closed the wrong one. Oh. Here we go. We can see that there's an instance of MSEdit with this port number. If I start up, here we go. my desktop here. So there we go. So I start up. This is a little demo program. So he says he's got one connection and he's found 0 other clients. If I run the second copy, he says he's got one connection and he found 1 other client. So if I list the names here, they've just found each other. They've both got 2 connections on, and we can see that he's sent his name. If I want to change the name here, call him Harry. So he's sending. They don't actually send anything. There you go. He's asked, does the name Harry exist? He sent it to the 57 server here, and he said he didn't reply. So obviously that's. So if I type Harry here, we can see here exist Harry, sending used Harry to, and he replied used Harry. So there we go. So if I open my editor, see if we can get another editor open. Open another program here. Finish loading. So here's another one. This one's called Presto.decom. If I change the name here, up. Look at the same thing. Session is already in use, and it will refuse to change the name. And here, if I want to open this file, I can see that there's one other editor, and it'll just open it in the other editor. So it's just a quick sending through. So the big problem was just the discovery problem. Is anybody here going to tell me that using DDE server or the WinInfo server not allowed? No?
I've seen sites where the X11 servers will block messages.
But I don't. The messages aren't going through the X11 server. It's just the only information that's going through is just the identity.
The mechanism that WINFO uses to discover other interpreters goes through the X server.
Right.
So,
It's
and
done.
you can block that in the
It's
X
done
server.
via property on the root window. But I've never seen anywhere that actually blocks.
I have.
Hmm?
It's a security hole.
It's blocking
Yeah,
in the same machine. I know it does if you go from 2 machines
Yes.
to the same display, but
But the point of the mechanism here is to have several instances of the same program via.
Are these long-running processes? Because with DDE in the past I had some problems with memory leaks.
But I'm not using DDE. I'm just saying my name is, and that's it. I don't use DDE to send anything.
Limited use of the. It's very limited use.
So basically, I use DDE as my identity server, and that's all. The rest of the system is very just like the COM system, where each application has its own server, and they connect. And then if one of the programs closes, the socket server detects that the connections, and it just deletes the. So the only information it restores is the socket ID and the port and the file ID of the open socket.
A lot of what you're doing is also built into DBus.
DBase.
I don't know if you came across that in your research.
DBase.
DBus.
Ah, yeah, but that's only on the Windows.
That's-
Does
well,
Windows?
you can compile it for Linux, for Windows, but it's
Yeah, but we have to.
default available on Linux, and you have
Right.
different version of different things for
Yeah.
Windows anyway. So.
But we're running installed user Windows installed by the CNES.
Yeah, okay. But so
So-
you have DDE there, and if there's a problem with the X messaging, then DBus.
But apparently they've been using it for nearly a year now, and
Okay.
we haven't had any. The socket server works on all their systems. So being able to open a socket server, the old mechanism has been working for the last 15 years, I think, on their site. Obviously, every time they introduce a new Red Hat system, there's more and more restrictive on it. So we have the /tmp, which isn't executable. So star packs, which send out try to load The DLLs don't work anymore, SOs, yeah. So we're working our way through that. So here we go. This is the. If I come back, losing all my windows. Here we go. So if I come here, I can see now that we've got one Presto plot, which is the tracing program, and one MS edit and two tests, two MS edits and two tests. So each program just only looks to see for the name. So I can have a Presto plot up, if I can get it here. So what have we got? Harry, what I use? There's a big problem with this. Apply. So I can change my name to Harry and still have a test Harry. Just a tiny little window. There we go. So they don't. The applications are completely independent of each other. And anybody got any more questions, or want to see something else?
If there aren't any questions, thank you, Martyn.